Good morning all, it's Postbag. Straight in, no mucking about. Let's see what this one is. Well, it's JST connectors, but I can see a problem here immediately. They're too small. They were meant for this, but that's a tiny little miniature 6-pin JST. That's obviously not compatible with this. What did I buy?
Yes, this is embarrassing, really. I bought 5 sets micro JST SH 1.0mm. Now, I didn't even see that 1.0mm, or at least it didn't twig what that was. 6-pin female connector with wire and a male connector. $1.88 if you want this actual item. Free shipping, and this one came from Mesh.
Yeah, so this little 1mm pitch is less than half the size of this, or less than half the pitch. This is 2.54, of course, 0.1 of an inch. That socket looks like it's actually a surface mount designed to mount on one side of a PCB.
Right, I clearly need to educate myself on JST Connect. So what have we got here? Well, the SH, the one I bought, 1mm, actually looks like it's the smallest one of the whole lot. 2.50mm, not 2.54, but it's pretty close. I want either XH or EH. So that's the error I made, unfortunately. So this is the sort of thing I want. 10 pieces of, now they don't say 6-pin, they say 5S1P because it means 5 cells in series, 1 in parallel. That's actually relevant. So that's 6-pin. I mean, I can see they're 6-pin from the diagram. Silicon balanced charger cable, silicon. I wonder if they really are silicon, but there it is. It's the JST XH connector, male, female plug. And they've obviously got wires on. So that's the one I want. So I'm going to have to order that now.
Okay, next up is this. What's that? And it is, oh, okay, this is a buck converter, I think. Yes, I think it's got, I think it's a fixed 5-volt one. That's right, because there's no pot on there. And there's a USB out. So it's fixed 5-volt. Input is whatever the chip will handle. It's synchronous. You can see there that it has 2 MOSFETs. So it's a synchronous buck converter. So it should have high efficiency. Let's get rid of that. It also has this rather nice coiled or stacked flat copper coil inductor. I took one apart on a recent Postbag when I got one of these in. So, well, let's have a look at this on eBay and just check out the spec.
So this one is a DC to DC, 9 to 38 volts on the input, or 12 volts, or 24 volts on the input, to 5 volts on the output, 5 amps, so it's a fairly high current, buck step-down regulated power converter module car. It was $6.20, free shipping from Liang.
Well, I suppose we could give this a quick power-up test. Pause doesn't line up with pause, so I'll flip that over, poke that in those holes. Right, just 12.8 volts on my solar power system today. Oh, a very bright blue LED. Now we need something to plug into that USB output, so how about one of these little lights? Yeah, that'll go straight in there. Ooh, I say it'll go straight in there. It's pretty tight. Crikey. And there's nothing coming out, so am I doing that right? Yeah, that's correct. Did something get bent when I did that? Yeah, not having a lot of luck with these synchronous rectifier buck converters, am I? Because I think by shoving that little light in there, I think probably the thickness of the board was just a bit too much for those pins, and they've all been shoved back in their little slides. So unless I can flatten them out again, that USB socket is knackered. And this thing's getting strangely warm, even without any load on it. I wonder if it doesn't like having no load on it. I think most of the heat's coming from the actual control chip, but the inductor casing feels warm. Yeah, and that chip feels warm as well. That's strange. Let's have a look at what that chip is. Right, well that's a Texas Instruments 40057, so let's have a quick look for that.
So this is the TPS 4005X wide input synchronous buck controller. Operating input voltage 8 volts to 40 volts. Now it says up here the TPS 40054 is not recommended for new designs, but that doesn't apply to the 4057.
Right, I suppose I should just check the output of this before I connect it to anything. Pos is that side. Yeah, well that's a pretty stable and accurate 5 volts. Let's just feel how warm this is again now. I mean, it's not hot, it's just warm, but that's a fair amount of heat being generated there. That's a fair amount of loss. Okay, let's see if I can drive something with it. Right, I've put a male plug on the 5 volt output, so if I plug that into my NeoPixel Ring project, because that microcontroller takes 5 volts, the pixels themselves take 5 volts, that should... Oh, switch. Yep, that seems to work. It's supplying 5 volts to the microcontroller project. Well, it works, it's just surprisingly warm. Not sure about that. I mean, for a synchronous buck converter, which is supposed to be highly efficient, don't like the fact that it gets warm when it's off load. Right, next up is this. What's that? Well, it's quite small. It's got a USB micro input socket, an inductor on the back, a little control chip, and a couple of connection points. Oh, I think actually this is a cell charger. I think this is a bit like the TP4056, but different. Let's get in close. So yeah, I think this is a lithium cell charger. I've got a feeling it's 2 amps. Let's just see if we can see that chip. Well, it looks to me like it says something 400 or possibly 4001, but it's a bit indistinct. Let's look at eBay first, see if we can get some clues there.
Well, it's it's a mini 4.2 volt, 2 amp micro USB 18650 lithium battery charging board, LED charger module, $2.70, so it's pretty inexpensive, free shipping, and this came from Ianhu81, and I've actually identified this chip. It's Linear Technology LTC 4001-1 2 amp synchronous buck lithium ion charger. Synchronous. Did this have an inductor on it? Yes, it did. So it's actually a switch mode charger, unlike the TP4056, which is linear, despite the name of the company that makes the chip. So preset 4.1 float voltage with plus or minus 0.5% accuracy. Is that what eBay said? No, this says charging cutoff voltage 4.2 volts plus or minus 1%. That's odd. Actually, it says here this 4.1 volt version of the standard LTC 4001 is intended for applications which will be operated or stored above approximately 60 degrees C. And here it says 4.1 volt float voltage improves battery life and high temperature safety margin. So it's probably actually not this chip. I'll have to see if I can find the standard LTC 4001, which probably is 4.2 volts. Yeah, here it is. It's this one, and it probably says pretty much the same stuff with a preset 4.2 volt float voltage with plus or minus 0.5% accuracy. 2 amps maximum charge current, no external MOSFETs, sense resistor or blocking diode required, which is interesting because there seems to be a diode on the board. It's probably an anti reverse polarity diode. It utilizes a 1.5 megahertz synchronous buck converter topology to reduce power dissipation during charging. Yes, it's not going to get as hot as the TP4056, which is linear. This one is switch mode. Yeah, this isn't going very well, is it? Because this is a low profile 16 lead QFN package. And it has quite a lot of connections on there. And there's the 16-pin QFN package. The problem is the one on the board is an 8-pin small outline. So I don't think it is this, which is weird because it's got a very similar number, and it's switch mode, but it's obviously not this chip. Oh dear.
Well, that says LI or L1 4001 or LI 4001 or LI 400. I've searched all combinations of that and I can't find anything, so I can't identify this chip, unfortunately. But I mean, this could be quite a good charging board. I just don't know what chip it uses. Right, moving swiftly along. God. Oh dear. I mean, what do you say? I mean, what is there to say? I don't expect I'll find data sheets for these. Interesting.
Hello, lad. What's up? How you doing, lad? You alright?
Yeah, I'm fine, yeah. So, does this qualify as the worst Postbag video ever? Or will one of these items actually be something worth talking about, worth looking at? Or has the whole thing just gone completely wrong? What's this? Oh, that might be quite interesting. So this is a diode, although it doesn't look like a diode because it isn't a diode, it's actually two MOSFETs, or at least that's what I believe it is. I wonder if I can peel that heatsink off so that we can take a look at what's actually on this board. So this is an ideal diode. Now it's not a two-terminal device because it's active in effect. There doesn't seem to be much circuitry on here. There are two devices which I think are in parallel. I'll have to have another look at that, but they don't look quite the same. One is beveled off and the other isn't. These are stuck on with, or the heatsink's stuck on with silicon sealant, it would seem, because that stuff was just was rubbery. I pushed a little bit away on the side there. I would like to know what those devices are. There are other ideal diodes on eBay, but I particularly like this one because of the connections were on sort of input one side, output the other. And but the heatsink unfortunately obscures what components are on there. Let's take a look at that on eBay.
So this is it. It's a solar anti-reverse irrigation diode. I'm not sure why they keep calling these reverse irrigation. I think some of them are called anti-reverse irrigation. They have some weird names. Battery charging constant current. Constant current? I don't know whether that's true. Module. So this is basically an anti-backfeed diode for solar, but it's an ideal diode. So it doesn't have the volt drop of a standard diode or even a Schottky diode, because it uses 2 MOSFETs. Now I assume these are 2 MOSFETs, even though the package styles look slightly different. I'll sketch the circuit in a minute. Anyway, this is $4.63, free shipping. This one came from Chip World, but it's worth looking at others.
Well, I'm a bit mystified here because it looks to me like what this is a couple of probably N-channel MOSFETs in parallel. They're in parallel. The diagram's a bit of a mess, but the source is connected to the other source and drain. They're just in parallel. But there are a couple of Zener circuits, is what it looks like. This resistor is 10K, and there's another duplicate circuit here, 10K with a Zener. And the Zener, the point between the 10K and the Zener goes to the gate. So the gate is just held at a fixed Zener voltage, pretty much irrespective of what the input is. And I think on the listing it says that can be anywhere from 5 to 60 volts, which makes sense. But the thing is, the anode of these Zeners would have to go to this ground line, this 0 volt line, which is from in minus to out minus. But they don't. They seem to go to source. So it's almost as though the back end of this diode is connected back up to here. And actually, from what I can tell, and I've been shining a torch at this thing, nothing seems to connect to this ground line. Unless this is more than 2 layers board, because all these wires, I've followed them through to the other side. So I just can't fathom this at all. It's really weird. So I think you can see that there doesn't appear to be anything connected to this minus line, this negative line on this side of the board. And if you flip it over, there's nothing connected to it on the top of the board either. And there are no wires through. These wires here, which look like they get close, it's a horrible design, but someone's actually sort of run that around them. Those are the 2 MOSFET sources, from what I can tell. These are the drains. And the gates are on these little Zener diode circuits, assuming these are Zener diodes, but I think that's what they are. So the only other possibility is that there's something underneath these terminal blocks, because I know there's quite a bit of space under there. But yeah, that's really weird. I can't fathom that at all.
Now, further down the eBay listing, take my glasses off, we've got a little bit more information here. Again, you can see this track running down here. There's no wires through to it, and that is the negative line. So unless there are some components underneath these terminal blocks on the other side of the board, it doesn't look like anything is connected to the negative line. Won't work, will it? Solar anti-irrigation diode, block name mode 15 amps over the anti-backfeed diodes, operating voltage DC 5 to 60, operating current 15 amps max, peak 18, without heatsink to work long hours in the 10 amps. Can be used in parallel, so you can parallel these things up. Quiescent current 0.2 milliamps at 12 volts. Now that's going to be the current flowing through that diode, I presume, the Zener diode. A small quiescent current just to keep that MOSFET gate voltage constant. Anti-solar panel irrigation, a variety of battery charging anti-irrigation. Oh, it's just nonsense, isn't it? It's all nonsense. Now, if you do a search on eBay for ideal diode, you get various things. There's one here, 15 amp solar panel anti-reverse irrigation module. Now this has 2 MOSFETs on it, so that's 15 amp. The one below, 8 amp, has just the 1 MOSFET on it. But these have a little 6-pin SOT23 looking type device. Let's click through to that item. Right, actually it's a 5-pin SOT23, that device up there, but there's also a transistor there. So there's just more circuitry on this design. There, again, you know, there are the 2 MOSFETs in parallel, presumably, to get that 15 amp rating. On the single MOSFET one, it was 8 amps. There's a little heatsink on the back. Can we see any more detail on how that circuitry works? But it looks like that SOT23 is some sort of controller. Now, does this one that I've bought have that on it. Is there something maybe hiding under those connectors? I think they're going to have to come off, you know.
I think in the interest of science, I'm going to have to find out what these MOSFETs are, so that heatsink's going to have to come off. Now, I can probably still use it even without the heatsink, because I want to know what those MOSFETs are, so I'm going to give them a bit of a scrape now. And this is definitely silicon, because it's just peeling away like rubber. And yeah, I'm pretty sure they're both N-channel MOSFETs. The one on the left is B75NF75. The one on the right is a B75NF75. Despite the fact that they're in two completely different packages, they are actually the same thing. So let's take a look at the datasheet for those.
So yes, this is an N-channel 75 volt. Oh, what's that? 9.5 milliohms, 80 amp or 75 amp MOSFET N-channel. So yeah, and they're just in parallel by the look of it.
Well, maybe the next thing to do is to see if it passes a current. So I'm going to put 12 volts in there. I think it said the range was 5 to 60. This is actually a 24 volt bulb, but it doesn't really matter. So let's get my solar 12 volts and just see what happens. And yeah, I mean, that passes a current. Now I'm going to measure the voltage drop across these MOSFETs. Well, across the diode. This is effectively a diode. So I'm going to measure the voltage from in positive to out positive. Right, something smells very weird, but I think it's the bulb. I don't think it's the circuit. Right, the volt drop is 0.64 volts. 0.6 volts. That's not an ideal diode. That's a normal diode. 0.6 volts. A volt drop. That can't be right. Those would be getting hot, wouldn't they? Let's see if they're hot. Well, they're not hot. They're getting slightly warm. But that can't be right. 0.6 volts. I'm going to get a Schottky diode and see what the volt drop on that is. Right, here's a non-ideal diode. It's a 10SQ045. So it's a 10 amp Schottky diode. Let's connect that up. And that has a lower voltage drop. That's 325 millivolts than this, which is supposed to be an ideal diode using MOSFETs. But this had a 0.6 volt drop, which is what you expect of a regular non-Schottky diode, just a standard diode. So what's the point of it? And this diode isn't getting warm at all, really. Only dropping that small voltage. There's nothing happening there at all. I think what's going on here is that it's just going through the body diodes, because you've got these two body diodes from source to drain. So there's a body diode there. These are in parallel, so we've got two body diodes in parallel. But I don't think this circuit's working active at all. It's just the body diodes, of course, are standard silicon diodes. They're not Schottky. So we're just feeding this through two body diodes. I really don't think anything is connected to this ground line. The MOSFETs are just providing a diode function by virtue of their body diodes, but what's ideal about that?
So maybe, I mean, I don't want to give up on these ideal diodes, because I think it would be actually, well, ideal for me to use with the solar charge controller, because my PWM5 had an external diode and it wasn't ideal. I mean, it was actually one of those Schottkys, and it got warm. So if I could put an external diode on, I wanted it external because I wanted it to be able to be there or not there, depending on whether you needed anti-backfeed. But if I put one of these ideal diodes on the output, now this isn't an ideal pinout with input, output and ground. I quite liked the in on one side and out on the other side of the one I bought, but it don't work. So I think I'm going to buy one of these, maybe one of the 15 amp, maybe one of the 8 amp. And when they come in, I'll have another go at seeing whether these ideal diodes are any better than Schottkys. But the one I bought, isn't, is it? Doesn't look like it.
So these are today's postbag items. Now they've been a bit of an unmitigated disaster. These were the wrong size. This thing I broke because I shoved something into the USB. It does seem to work, but it gets warm and that worries me that it may not be totally efficient. This thing had a high voltage volt drop and therefore isn't as ideal a diode as it makes out. This little charger board might be okay, but I still haven't managed to identify that chip. Hello?
It was an unmitigated disaster.
Well, it's a bit strong, isn't it? So I think it's time to continue with the robot build because I think I've had enough of opening post today. It all went a bit wrong, didn't it? So let's break all these green parts out. Now I noticed that there are a lot of these little sprues, these injection molding sprues on there, and particularly on things like the gears. That could be a problem, so I'm going to have to go around and trim all of those. So if you enjoyed this video, up here there are a couple more videos that you may enjoy. If you want to subscribe to my channel, well, touch my face. And this link takes you to my other channel, Julian's Reviews, in case you're interested in watching those.
I doubt anyone will be wanting to watch your videos after this nightmare.
Yes, thanks, Grandad. Cheerio.